we're now recording object-oriented programming. So this is going to be our big topic for the next 2 weeks or so. We're going to be learning object-oriented programming. So I'm going to delete my Zeta solution there because it's terrible. And I'm going to make a new one. And we're going to talk about the difference between procedural and object-oriented programming. So procedural programming is all the brains are in main, basically. Like main's the director, it's the dictator. Like in our Zeta function, it's reading an input, and then it's calling a function and getting work done and getting a result back and printing it and stuff like that. It can call functions and things like that, but basically it's directing the show. With OOP, the brains are in classes. Okay. And we're going to learn something called proper class design, and I always put quotes around that because there's really no such thing as proper class design, but we're going to learn a set of principles for designing classes. Like I said, in CSI 40, we learned a really basic way of doing classes. In CSI 40, so CSI 40, we did procedural programming, and we did classes are all pods, plain old data, a bunch of variables together. Yep. So like we did things like this, like struct person with an age and a name and an address. Right. You guys remember this kind of stuff? Yeah, I got you. So do you guys understand this? Like this is the CSI 40 way. It's basically a bunch of variables together. Not a big deal. It's pretty easy. You make a person down here and person Bob, and we can say Bob's name is Bob Jones. I don't know. Are you getting another homework assignment today? No. For a good reason. Your Zybooks is quite large and voluminous. And so I would like for you to focus on doing these Zybooks for now. You'll get your next homework assignment on Friday. And until Friday, I want you to actually just start digging in hard on the Zybooks. It's quite big. It's quite longer than the first one. I made the first one quite short because it's the first week of school, and it's really just there to get you oriented, make sure you bought the textbook and things like that. Just like how FizzBuzz was a 2-point assignment to make sure you understand how the autograder works, how deadlines work in this class. I had a couple people like, I didn't know it was on noon, and that's why it was a 2-point assignment. So if you flub it, who cares? Not a big deal. Okay. All right, girl. All right. They've all seen it. They've all laughed. You can put your hand down now. Okay. So this is the CSI 40 way, and the CSI 40 way, by the way, isn't bad. I said this in the previous class, and I'll say it to you all. Just because you're learning a new way of doing things doesn't mean that it's better than the old way. Procedural programming is fine. Pods are fine. Plain old data is fine. It's
what
used.
Are pods?
It's when you make a variable that's just a bunch of variables together. Like
that isn't very clear.
Like a person has an age, a name, and an address.
Okay, that's a variable?
That's a variable, yeah. So every person has a name, an age, and it. So if you make a person named Bob, you can set Bob's age to be 9, and Bob's address to be Hawaiian duck. Okay.
Speaking of which, that's the name of the duck you just saw.
Oh, is it? That's how weird. Okay.
Daddy, it's showing it's on my computer. My laptop.
Is your Zybex assignment the 300.1? Yeah, it's
Daddy,
the 300.1.
Daddy.
It's all of chapter 7.
Daddy, this thing is happening.
Just click on one. Hugh's last chance on Zeta. Yeah, if you want, I can go for it, I guess.
I'm just gonna say Daddy.
Go for
it's
it.
not just work. I wish this wasn't happening.
There we go. I'm in class.
Make your computer easier to use.
Okay. So we're gonna be doing.
Daddy, it's like, please read the license agreement.
Ada, I'm in class, girl.
No, but like I need to do my homework.
Bring it over.
It's like I can't do anything about it. It's just popping up the whole screen. It's not like a part of the screen. It's like the whole screen.
Just hit OK or something. Accept. Yeah. There you go. All right.
Okay.
Okay, so let's talk about proper class design. So proper class design has the following attributes. All your variables are private in general. These are general things. They're not hard and fast rules, but in general, that's how it is. All your functions are public. You hide how you actually implement the class. You provide an interface to the class that is stable. So for example, in the previous class, nobody knew how vectors compute their size. Does anyone here know? TAs don't know. Anyone know? So when you have a vector and you call dot size, right? It'll say there are 7 elements in the vector right now. Does anyone know how that is held? Is it a member variable called size or something? Anyone know how it is held? Does it iterate through and increment a counter? It absolutely does not count. That would be an order in operation. So if you had 1 million elements in the vector, it would go through and count 1 million elements and be like, okay, it's 1 million. No, it's order 1. It does one operation, essentially, and not n. Does it keep an array in the class? There is an array somewhere deep within the class. There is an array, but that doesn't matter. I'm asking like, how does the vector class keep track of its size? How many elements it has in it? Because there's actually 2 things in a vector. There's how much memory it has allocated, and then there is how many elements you have in the vector. Those are 2 different things, because the vector will fill up, and then when it gets full and you call pushback again, what happens is it allocates a new array that's twice the size. It copies all the elements over, and then pushes back the new element into it. But how do you keep track of the size? Counts the bytes, stores a variable. Yeah, so nobody knows. Right, you're all guessing. And that's fine. That's actually the point. The point is, it doesn't matter. That's the point. The point is, it doesn't matter. If you make a vector of Bobs, or vector of persons, let's say. Vector of persons, and vec, and we're going to vec dot push back a 9-year-old named Sally, who lives at 111 Main Street. Add a few people. Who cares? They're all the same name. It doesn't matter. They're all clones. And then we see out vector.size. What number is this going to output? It doesn't hurt to be curious. Yeah, exactly. Like, I'm curious too. Like, whenever there's a standard library thing, I'm actually curious, like, how is it implemented? But the secret here, the point here, actually, it's not even a secret. The point is that it doesn't matter. How do they do it? I don't know. It doesn't matter. Because as long as .size returns the right number, 4, very good, I don't care how they do it. Maybe they have a variable that tracks the size. Maybe they don't. I think the actual way they do it is that they have a pointer to the beginning of the vector, they have a pointer to where they're currently writing to, and they have a pointer to the end of the vector. And they do a pointer difference. They subtract the 2 pointers from each other to determine how many elements are in it. They don't actually track it separately. So that's how I think it's implemented, but it doesn't have to be. If somebody came along and wrote a standard library implementation of vector that used an integer to track how many elements it had, I wouldn't know. Why? Because the interface is this function here, right? You have the interface is this. All your functions are public. They are the interface to the outside world. If you ever heard the function the term API before. An API is the application programmer's interface. You provide a set of functions that people can call, and how you do your business over there in vector world doesn't matter to me. And this is called separation of concerns. The person who makes the vector class doesn't care about me, and I don't care how they made the vector class. I just use it. Okay. The only time it's going to matter to me is if there's a bug, right? Like if I call .size like this and I get 2, I'm like, huh? No, that's wrong. Because their interface, they made a promise, they made a contract with me that size would always tell me how many elements were in the vector, and if they returned 2, they broke the promise, and that's a bug. Okay. So I run this, I get 4. Good. Do you guys understand? So I don't care. The vector people do their vector things, and I, the client of their code, use their vector. And we don't talk to each other. We don't email. I don't need to know the names of their member variables. As I just need to know the interface. There's pushback, .at, .size. Okay. Does that make sense to you? So it's a separation of concerns. So object-oriented programming is very commonly used when you have a big project and you have different people working on different parts, and so they'll make a class like vectors, and as long as people stick to the interface, I can actually sit there and change how vectors are implemented under the hood. Like if I wanted to, I could go and rewrite the standard library right now on the server. I have the source code for it. I could actually rewrite it right now so that it used an integer to hold the size instead of a pointer difference, and nobody on the server would know. Okay, that's nice. That's actually a nice thing, because that means that I can do bug fixes and things like that. I can actually make improvements to it without breaking anyone else's code. Private is meant for the creator of the class, not the user. That's exactly what private means. Yeah. So let's do this. Class. We're going to be doing classes now, not really structs. Structs and classes are the same thing. Technically, structs default to public, classes default to private, but they're the same thing. That's just the only difference. But when I, as a programmer, see struct, I'm assuming you're using a pod. You're making plain old data as just a bunch of variables together. And there's nothing wrong with that. That's just the connotation that the word struct has. That you're telling me, without telling me, that it's just a bunch of variables together. Okay. If I see the word class, the implication is it's not a pod. It's using proper class design. Okay. So I'm going to make a vector class of my own, and I always use capital V because all of the standard library stuff is all snake case, lowercases with underscores like this. Okay. And so I'm going to make my own vector class and show you guys how this works. And so I'm going to start off with the private section. The private section, it's private by default, but I can put private here if I wanted. And so I'm gonna start off with just an array of 100 integers, and I'm gonna say to do fix this nonsense. But I just want to get it working. Okay, I just want to get it working to begin with, and then I'm gonna make it better. Right? That's how you should always approach programming. Is just get it working. Always have something that works, and then tinker with it and make it better over time. So my vector is not going to work with more than 100 numbers, but again, we're just getting it going. And I'm going to have an integer for the size, and I'm going to call this underscore size. It's going to default to 0, and I'm going to 0 fill the array just because it makes me happy. And then I can have a public section, and again, I could just delete private. It defaults to private, so it's all the same. But I just kind of want to make it clear what's happening for you. And so the interface to vector that I care about would be .size, .pushback, and .at. those are the three that I care about the most. I'm not going to do the whole thing. So dot size is going to return an integer. So I'm going to make a function called size on it. And it's just going to return underscore size. And if you wondered why I put an underscore there, it's for that reason. Because the function's called size. Right? I could have called it something else. I don't know. I can't come up with good variable names. Underscore size will work. Then I need pushback. So pushback is going to take an int. And pushback is going to go into the array. So currently, if I have 0 things in the array, then array size equals x. So if I have 0 things in the array currently, then array square bracket 0 is going to be equal to 42 or whatever number I'm pushing into there. And then now that I have added something to the array, the size goes up by 1, and that is underscore. Yeah. And there we go. There's pushback done. Add bounds checking and stuff. So this is not going to work once you go past 100. You know what I mean? And then we need at. So at's going to return an integer, and we're going to return array index to also add bounds checking. Right, we're just writing the minimal implementation to get it going, and this is a fully operational vector that will hold at most 100 integers. And if you dot at a negative index, it'll segfault probably, and if you dot at 500, it'll segfault, and if you push back too many times, it'll segfault. But we're getting it going. Okay. So rather than this whole thing here, let's make a vector named vec, of course, and we're going to say vector.push back, and we're going to push back 42 and 20 and negative 42 and 2 and 4. Okay. And then let's print it out. So we don't have the ability to do range-based for loops with it because you have to have support for that in your class. But we can do a regular for loop. So we can say int I equals 0, I is less than vector.size, I plus plus, cout vector.at I. And this should, if everything worked right, print out 42, 420, negative 42, 2, 4. Yeah, there you go. You see that? So, yeah. So we have a number of things that we need to fix with this. Are there negative octals? Sure. Yeah, you can have negative base 8, negative base 16. It's fine. Nothing wrong with that. So I've now made a vector of integers of size 100. It's always a vector of integers of size 100. So there's a lot of ways that I could make this better. First thing, I will do a little bit of C++ magic here and just combine those two lines like that. It's not any faster, but some people in the previous class didn't know you could do this. And so what this is going to do, like let's say the first thing's initialized to 0. So this is going to write into array 0 the number 42, and then after the line runs, it increments size by 1. And this is a very common way of programming these kinds of things. You'll see the postfix ++ operator like that. And the student didn't know what the difference between that and this was. If you have the prefix operator, then it increments it before the line runs. And so it would write into array 1 the value of 42, and the size would be 1. And so array 0 would always be 0. So this is the right job for it. Sometimes you do use prefix. It's just whatever you want. Looks sketchy. Yeah, it does make people nervous, but that's kind of why I'm doing it here. So you can see, because you will see this in professional code. And so it's best to just kind of get what's happening. you'll see things like this, like while star pointer pointer plus plus equals star pointer 2 plus plus something something something. And so what this will do is it's going to if you have 2 pointers, it'll compare them, and then it'll move to the next spot, and then move to the next spot, and then move to the next spot, and it'll terminate once the thing they point at is different. So it's like string comparison, basically. And so that's you like at Berkeley, they love writing code that way. It's a stylistic thing. Your head hurts. That's fair. It's fair. But that's why I'm showing you in class when it's low stakes. It's just a lecture. So what should we fix? Take your pick. Got a random severed head in the background, severed hand in the background here. Bounce check. All right. Which one? Pushback. At. Let's do at. That hurts my brain more than anything. That at doesn't do bounce checking. So okay. So if index is less than 0 or index is greater than or equal to size, throw runtime error out of bounds. Foo. Yep. So there you go. So if we try accessing .at -1, it'll insult us.
What?
Let's make sure it works. There we go. And then let's try
saying bounds checking?
vector.at.
How am I saying bounds checking?
You want to... There we go. Okay, so there you go. Bounds checking's done, at least for this one. So basically, if you got 5 elements, if you try accessing element 6, it doesn't exist, right? So if you have like 5 apples, and I say, give me the 7th apple, there is no 7th apple.
So you said that like sometimes numbers only go up to like 10, or like 7, so like 6 plus 7 would be like 6.
My daughter is talking about modular arithmetic from Seaside 26. You're gonna break their head, girl. You're gonna break their head. Mincarelli and.
Well, you better get it into your head so you got a head start.
Yeah. They Hazelton, yeah, yeah. So, you're telling me I could download and change the standard library to throw error messages with pirate quotes?
Yeah, teach them. It's not that hard.
I'm not getting into modular arithmetic.
Why?
In CSI 41.
Why not?
Because it will hurt their brain more than needs to be hurted. Their brain's going to be hurting enough as it is. But thank you, Ada.
You can save it for another day to torture them.
So yeah, we learned why
Just do like
8 divided by 2 equals 7 or
Just give them like a brief thing.
Okay, with modular arithmetic, if you go past the maximum, it wraps around to the minimum. There you go. Okay.
And how many numbers are there?
So if you have Z8, the numbers exist from 0 to 7. So 7 plus 1 is 0 in Z8. There you go.
It says from 0 all the way to 7.
Yeah, it's like a ring space in math. Yeah. So, modular arithmetic, Rubik's cubes work that way. If you rotate a Rubik's cube 4 times, it goes back to the beginning, right? Okay, let's do bounce checking for pushback. If size, if we have is greater than or equal to 100, then we will throw a runtime error. A death awaits you all, nasty big pointy teeth. Okay. All right, so there you go. Bounce checking's done. I don't like these magic numbers here.
What are magic numbers?
So it just has the number 100 there. What if we want to change this?
I've heard of the magic 0, but not the magic
What if we want it to be size 200? Now this thing's not going to work, so we'll probably need a static constant max size equals 200.
Dad, you're not paying attention to what they're saying.
Max size. Yeah, I see it. Max
Dead
size.
men tell no tales.
There you go. That's better, I guess.
You're supposed to be doing work.
What if you call vector at the top of your code? I do have vector at the top of my code. That's why my vector is capital V vector, right? And this is an issue that people who love STDs bring up, which is that they're like, well, how do you know which vector you're calling? Are you calling the standard library vector or yours? I'm like, it's mine. It's got a capital V in it. Nothing in the standard library is camel case or Pascal case. The standard library, everything is lowercase, snake case, right? So this is the, I can't have two vecs. So this is how the standard library makes a vector of 200 integers. This is how I do it, okay? And the dot pushback is just based on whichever one we have. This is my class. It's calling my pushback. This is their class. It would, if I called ogvec dot pushback, it would call these standard libraries pushback. Okay. What about the use of namespaces? Namespaces are good and useful and stuff like that, but like the people, there's a lot of people online and different professors that really hate the use of using namespace STD because they're like, well, how do you know that you're getting the standard library vector or not? I'm like, because it's the standard library one. I just don't write code that conflicts with it, you know. So simple as that. You know, 20 years I've had a problem come up once, and it was basically like this, and then it was like ambiguous reference. I'm like, oh shoot, I just came up with the same name as something in the standard library. Let me fix that, and then it was fine. That was one time in 20 years. Whereas, you know, if you don't use standard library using namespace STD, then you have to spend your whole life putting STD : STD : STD : everywhere. To me, it seems like a good trade-off. I don't know. Are these all actually runtime errors? Yeah, they're actually runtime errors. If I were to run the code, it will throw an exception.
This is the computer science class.
This is my second semester computer science class, and so it throws an exception, kills the program. So if I wanted to, I could do a try-catch block around this and catch the exception, but I don't care. And same thing, like if I added too many things, YY 300 paste, then when I try pushing more than 200 elements in it, it throws a runtime error and it says death awaits you all with nasty big pointy teeth. So there you go. In practice, I would write a better. Yeah, you know what I mean? I'd write a better one, but 100 DD, and again, and again. There we go. So, all right. Let's see.
Can I type something?
I got 3 minutes left. I need to finish strong. So, so the next big thing that you need to do with proper class design is you want to have constructors to initialize all the things in your class, and destructors if and only if your constructor allocates memory. So what does that mean? Well, a constructor is a member function that has the name of the class that doesn't have a return value. And this thing here with the equals 0, that's actually modern C++. Back in the day, you'd have to write underscore size equals 0. You'd have to put it into the constructor. And you'd have to like zero fill the array in the constructor. Nowadays, you know, to me, like that looks better to me. I don't know. And so my constructor would be empty. But I need to fix this nonsense. So rather than a fixed size array, which doesn't make any sense for a vector, right? I would make a pointer, and I can delete the fix this nonsense now, and I am going to say r equals new int
No, you're gonna say I'm gonna get a 10 green.
max size. So I'm now going to dynamically allocate my array. And because I've newed something, every new needs a what? What is the rule of the Sith? Every new needs a corresponding so like a marathon runner, I need to finish strong. Yeah. you need a delete. And so the delete is going to go into something called a destructor. So this is called this is a constructor. And this here is a destructor. Okay. And destructors, they get called automatically when the variable goes out of scope or is otherwise deleted. Okay. And so we're going to delete square bracket R. And there we go. So now we are going to new memory. And if we wanted, we could zero fill it for and I equals 0, I is less than max size, I plus plus, R square bracket I equals 0, 0, 0 fill the array, just so we don't have any uninitialized things. And then when the vector goes out of scope, so here, it's going to allocate 200 integers, and here, when it goes out of scope, it frees up that memory. Yay. So if we did everything right, we can compile the code with the address sanitizer turned on and run it, and we don't get any memory errors. If I forget to unallocate the memory like that, I have violated the rule of the Sith. I have a new and no delete, and then when I run the code, address sanitizer is going to yell at me. You have a memory leak. A memory leak means you allocated memory, and you forgot to deallocate it. And it tells you where you screwed up. Here's where you allocated the memory, line 35, and it went out of scope, and yep, sucks to be you. Don't do that. So there you go. Put that back in, and then we're good on that. And then constructors, a constructor that takes no parameters is called a default constructor. We can also add a, constructors can also take params. So I can have a vector like this that takes an int new max size. And this would be exactly the same as this one, except it'll be new max size and size instead. Actually, let's just do this. So we want to write this down. Okay. So it's exactly the same code as before, except we're changing max size from the default of 200 to whatever number they pass in. So if I create a vector here with 1,000, this will make a vector size 1,000. Okay. Yeah, I love that meme, Hazelton. Well done. And so this is going to, you pass in 1,000 here, it updates max size. It's not a constant anymore because it can change. It updates max size to the new max size, and the rest of the code is the same. Now the way that I like to do this is I like to combine the two. So rather than all this going on here, I combine my constructors usually like this. And then this is do you guys remember last time when we talked about default parameters for functions? If you don't pass in a value, new max size will be 200. If you do pass in a value like 1,000, new max size will be 1,000. So this works as both. This is both a default constructor and a one parameter constructor. Okay. And so if I do this, it'll make a vector of size 1,000. If I do vector 2 with no parameter, this will make a vector of size 200. Okay. And that is, this is a working vector implementation. It doesn't grow. Like it's got a problem, which is that, when it fills up and you call pushback, it dies. Like we haven't implemented the reallocation and all that stuff, but this is a working, data structure. Okay. It's a variable size array. Let's put it that way. It's not really a vector just yet. It's a variable sized array where you can specify an array of a different size, and it fills itself with zeros. You don't have any uninitialized values in it like you would have used an array. It's heap allocated instead of stack allocated, so it's got that going for it over a array. And it does bounds checking. Like, this is actually a workable data structure that we just did in 20 minutes or something. Could you put this class into a header file and make your own library? Yeah, absolutely. Sure. Copy that. Yep. Then kernivec.h. What are you yelling at me about? Yeah. Include. What's the matter? Where are you? Where is runtime error? I think it's in std accept. No. Yep. No. No. Still doesn't. Where are you? What header file are you in? Std accept. Oh, yeah. See, this is what I'm talking about, using namespace standard, right? Just wasted a minute of 50 people's lives. So I forgot my STDs. There you go. So that's it. Yep. All right, and then main.cc. I can certainly include kernivec.h, and I can delete all of you. And there we go. It works fine. So we've got a kernivec, and everything works. Okay. So there you go. That's our lecture for today. That's I'll copy kernivec.h into public, so you can admire it at your leisure, and copy main.cc into public. Kernivec.cc. So kernivec.h, kernivec.cc are in public. You can take a look at them, admire them, appreciate them, print them out, and tape them to your walls as wallpaper. It will increase your intelligence quotient by 50 points. Sleep on it at night, put it under your pillow, and absorb the learning through osmosis. I'm kidding. It's only worth 1 IQ point. So, Kearney vector is not nearly as good as std vector. And we'll work on this more, but that's the notion. And so the notion is one person could be working on kernivec, and the other one could be working on main.cc. And if kernivec changes its implementation, my code here in main doesn't change. And if main changes, the kernivec code doesn't change. It's separation of concerns. Two different people can work on two different parts of the project, and as long as they stick to that interface, the agreed upon interface of things like .size, .pushback. What does .pushback do? What does size do? What does .at do? As long as everybody conforms to that contract, everything is fine. You've separated the implementation details away from the interface. And that's the beauty of object-oriented programming. It's not always the right decision, but a lot of times it's the right tool for the job. And yeah, we're gonna talk. This is our topic for the next week or two, and there will be a competency exam on it at some point. Okay, so that's it for today. No homework for today. Work on your Zybooks, and if you read through the Zybooks on classes, it's going to cover a lot of this stuff, and you kind of have to work with it a bit. It's a different way of thinking about programming. Procedural programming and object-oriented programming are kind of a different perspective, a different take on programming, and it kind of takes a little time to wrap your brain around it. So I would really do the Zybooks tonight, get it all done by Friday if you can, and then we'll continue our discussion of this on Friday, and have you guys starting to write your own first classes in proper class design on Friday, and you'll get your next programming assignment by then. And the side books is due on Monday. And there's a lot of, it's big, so good. All right, that's it for today, guys. Thank you for coming out, and hope to see you all alive and healthy back in person again someday. They're giving me a 10-day quarantine, so looks like maybe a week from Friday. I don't know. We'll see. All right. Peace out, guys.